If epithelial tissue covers the body, what's in the middle of the body between the epithelial tissue and the organs? Welcome students and all you curious folks out there. My name is Tarek, and today we're going to talk about the second type of tissue, connective tissue. This lesson is a supplement to the one on epithelial tissue. If you haven't seen it yet, go check it out. If you have, let's keep going. Connective tissue has a distinctly different set of functions when compared to epithelial tissue. It's the tissue that supports and connects other tissues, and it's responsible for support, diffusion, and the metabolic flow of cells from other tissues. In addition to occupying and filling the various empty spaces between organs and other tissues, the most defining and primary characteristic of connective tissue is its complex intercellular matrix substance, which is made up of a kind of jelly, an amorphous fundamental substance. Collagen fibers are primarily composed of a protein called collagen, and they provide an exceptional level of resistance to the tensions placed on them. Elastic fibers are composed of a protein called elastin and are directly responsible for maintaining the elasticity of various specific organs, such as the lungs, blood vessels, and the skin, which need to keep contracting and expanding all the time. And there is the amorphous fundamental substance, which is a transparent and homogeneous gelatin that fills the remaining spaces. In addition, another very important aspect of connective tissue is the types of cells found in it. The main cells are fibroblasts, which are responsible for producing intracellular material, and macrophages, which have the function. The primary defensive cellular components of the body are the plasma cells, whose essential function is to produce antibodies. Next are the adipocytes, which specialize in the storage of energy-rich lipids. And finally, the mast cells, which are primarily tasked with the synthesis and secretion of histamine, a substance involved in allergic and inflammatory reactions, as well as heparin. Connective tissue can be categorized into several distinct and specialized groups. That is, the connective tissue proper, which is divided into loose and dense types. It will show a homogeneous distribution of all structural elements. Those three I mentioned: collagen fibers, elastic fibers, and ground substance. And it serves as support and nourishment for the epithelia. It is found, for example, in the dermis. And it also appears surrounding muscles and blood vessels. Now, the connective tissue proper, dense, has a large amount of collagen fibers, among which elongated nucleus fibroblasts are found. This tissue is meant to withstand great tension. It is primarily located and found in the dermis and forms the tendons and the structures that securely connect muscles to the skeletal bones. In addition, we also have adipose tissue, which has large cells that, when fully developed, contain a substantial and significant droplet of fat, a compound that occupies and fills most of the cell. The adipocytes, which are these specialized cells, can significantly expand in their overall size as they accumulate fat inside them. This tissue is exceptionally well supplied with a network of blood vessels and has connective tissue septa that may contain blood vessels or nerves. The collagen fibers extend from these septa and offer a robust structural support system to these adipocytes. It is a crucial and primary long-term energy storage reserve. And it acts as a thermal insulator, preventing excessive heat loss or an extreme increase in temperature. We also have specialized cartilaginous connective tissues, which are a highly dense and compact structural network of collagen fibers, and in some cases, elastic fibers, which are thoroughly immersed within a firm ground substance where chondrocytes or cartilage cells are located and distributed. It is an avascular tissue. In other words, there are no blood vessels in it. And obviously, as the name suggests, it is found in the cartilages of our body. We also have bone connective tissue, which is a special type of connective tissue. And one of its most distinctive features is the presence of a calcified extracellular material, which we call the bone matrix. This matrix is it is rigid due to calcification, but it is also elastic because of the presence of collagen fibers. In addition to this matrix, bone tissue contains specialized cells, osteocytes, osteoblasts, and osteoclasts. Osteoblasts produce the organic portion of the bone matrix, while osteocytes are osteoblasts after they become trapped in the lacuna they themselves created, and osteoclasts are cells involved in the resorption of bone. As I mentioned, the osteoblast produces the organic portion of the bone matrix. This organic part is primarily and fundamentally composed of collagen, specifically consisting of type 1 collagen. The inorganic portion of the bone matrix is predominantly and structurally constituted, approximately 50% of the total mass, of calcium. This is what gives the bone its rigidity. In addition, we have connective, hemopoietic, and blood tissue. They are responsible for the production of blood cells and lymph, and are located inside certain types of bones. This tissue will serve as a precursor to red bone marrow. And we'll talk about bone and the blood system in another class.
I hope you enjoyed the video. Don't forget to like and share, and remember that we have a new video every week. So subscribe to the channel and turn on the notification bell to always get the latest updates. Thank you so much.